Hello 8th graders, we're looking at lesson 6 and we're looking at slopes of fitted lines or your lines of best fit, and in particular we're looking at how changing one variable changes another. Okay, to estimate the slope of this line, I'm looking at the 2 points that are closest to the line, and I'm looking at rise over run. My rise, I'm going from 2 down to -6, that's a distance of 8. Notice that I've actually labeled on my axis that 2 and that -6 to help me out with that. And then my run, I'm going from -4 to 5, so that'll be a distance of 9. So my rise over run is going to be 8 over 9. Now I know that that's a little high because my line is actually a little less steep than that line, but 8/9 will be a decent estimate here. We're going to use this graph as an example for what you're going to do next. We've seen this graph before, the weight of vehicles and the fuel efficiency of those vehicles. And I'm going to use this statement to kind of describe what's happening in this graph. As the weight increases, the fuel efficiency decreases. That means as the weight of my car goes up, the fuel efficiency of my car is going down. And one thing you'll notice is that when this happens, you'll have a negative slope, and we actually call that a negative association in the data. So you can use those terms going forward. So for the next 3 graphs, you're going to use one of these statements for each of them. Now, do note that you can use some of these statements more than once, or you may use some of these statements not at all. But these are just statements to help you kind of organize what's going on in each of the graphs. So try each of those and start again when you're ready. There is no line of best fit on these graphs, but you could go ahead and draw one. Mine would look something like that. And the second statement makes the most sense here. As the mileage increases, the price tends to decrease. And that's that negative association we just talked about. Here, my line of best fit would look something like this. And the statement that makes the most sense is the first one. As the weight of the diamond increases, the price tends to increase. And here we have a positive slope on our line of best fit, and we would say that has a positive association. This data is more scattered than the other graphs, but I still see a trend, and my line would look something like this. The first statement again makes more sense. As the temperature outside increases, the energy consumed tends to increase, and it might be because we're running more air conditioners. Now this is still a positive association. It's just going to be a weaker association because the data is more scattered than we've seen so far. In activity 6.3, we're going to do the first one together. This is where we are really looking at the slope of the line and interpreting what it means in that situation. So the first graph we're looking at is what we've been used to looking at with diamonds, the weight of the diamond and the price of the diamond. And the first thing we want to know is, what is the slope of the line? Well, looking at our equation, this is our slope right here, that number in front of x. So think back to that y equals, I'm going to write it over here, y equals mx plus b form. M was the slope, b was your y-intercept. So write that down. So our slope is 5,520 and 62 cents. And what is the meaning of that slope? That's the most important thing here. Well, let's draw a slope triangle that has a run of 1. So this looks weird because our scale on the bottom is going by very small increments. So to get an increase of 1 carat weight, we need to go all the way from 1 carat weight up to 2, which is about right here. And remember that slope is rise over run. So I could rewrite that slope as 5,520 and 62 cents over 1. So if my run is 1, which I already have, my rise would be 5,520 and 62 cents. And what does that actually mean? It means that if my diamond increases in weight by 1 carat, its price is going to increase by $5,520.62. So making that slope triangle, like this, where your run is 1, can be really helpful in figuring out the meaning of the slope. On the second graph, your slope is negative 0.011, and again, you can write that as rise over run. And so what does that mean? Well, I drew it in my graph. My run being 1 is going to be very, very tiny right there. My rise being my negative 0.011. And what that means is that when the weight increases by 1 kilogram, the fuel efficiency decreases by 0.011 miles per gallon. On the third one, the slope of the line is 0.59. Again, I could write that as rise over run. So on my graph, I create my little slope triangle, my run being 1, my rise being 0.59. And what does that mean? It means that when the temperature increases by 1 degree Fahrenheit, the energy consumed increases by 0.59 kilowatt hours. The first thing you're going to do here, I kind of summarize the questions a little bit. You're first going to decide whether each one of these could be modeled using a linear model, a straight line, or not. And if it can be modeled with a linear model, would that have a positive or negative slope? And then secondly, would that line show a positive association, a negative association, or no association? So you have to label two things, linear or not, positive or negative slope, and then positive, negative, or no association. Here's what you would end up with for each of these. Make sure you ask questions if any of these don't make sense. D might be the only one where you struggled a little bit. A linear model would not fit this data. It's just too scattered. And so we would say that there's no association in this data.